700 years before the crucifixion was invented, that was written. How many people, taken at random, have died having their hands and feet pierced? What ratio of people? If I say less than 1 in 10,000, I think I'm being generous. Okay? Take all the people that have died. How many have their hands and feet pierced? Very few. Okay. What we've done by this little exercise is go through 8 prophecies. Born in Bethlehem, riding a donkey, as a presenting king is riding a donkey, betrayed for 30 pieces of silver, the transaction occurring in the temple, the money ending up with the potter and all of that. We have wounds in his hands. We have no defense, though he's innocent. He died with the wicked in the grave with the rich. And, of course, he was crucified. Now, the question that faces us, okay, we've estimated probably rather conservatively a series of probabilities on each one of these. The challenge we have that's facing us now is what's the probability of a particular person in history fulfilling all 8 of these? We've got a rough guess for each one individually. Okay. What's the chance of a particular person fulfilling all 8? Well, that's an exercise in what we call composite probabilities. And to get a grasp of this, let me give you a little exercise here. First of all, if we were teaching statistics in school, and I say I want to get across the concept of 1 chance in 100, what do I mean by that? What I would probably do is have a bucket here with, say, 100 silver dollars in it. I'd take one of the silver dollars and put some nail polish on it or something, and then I'd mix the 100 silver dollars up in such a way that it's thoroughly mixed. And I reach in there, and the chance of my arbitrarily picking one that has the nail polish is 1 in 100. That gets across what we mean by 1 in 100 as a random probability. Are we together so far? Okay. Let's assume we have a population here, and let's assume there's 100 people here to make it simple. And let's assume that 60% of you are men and 40% of you are women. If I have someone blindfold and arbitrarily tap one of you on the shoulder, what's the probability that they're going to tap the shoulder of a female? Well, if you got 60% male, 40% female, the probability is 40%. Or the way we'd say it, probability of 0.4, 4/10. You with me so far? That's pretty straightforward. Let me change the problem and say, let's assume I have a population here that 60% of you are right-handed and 40% are left-handed. And for purposes of this exercise, let's assume those are randomly distributed. In other words, the probability of being right or left-handed is not affected by your gender, woman or male. Okay? So if a population is 60% right-handed and 40% left-handed, what's the probability if I was blindfolded and I tapped one of you on the shoulder that I got a left-handed person? Well, again, it would be a probability of 0.4 or 40%. We together so far? Now, here's the thing that is not intuitive that I want to get across. What's the probability of selecting randomly a left-handed female? Well, I take the one distribution of left-handedness, and I take the other distribution of male and female, and I put those two together, and the part that has that in common is the product of those two. In other words, the product there, it's 0.4 times 0.4, which is 0.16. In other words, out of 100 people, there's 16 out of 100 that I would expect. That would be my expectation on a purely random basis. Are you with me so far? The point I want to get across, the way you combine composite probabilities is take the product. If you have 1 in 1,000, 1 in 1,000, the combination is 1 in a million. Okay? Okay. Reminds me of the 2 statisticians that were flying on a plane. And the one statistician was sweating and nervous and very upset and frightened. He says, I'm really, really nervous about a bomb being on this plane. I've read so many news reports and so forth. His buddy says, don't worry, I've made a very careful mathematical analysis. And there's less than 1 chance in 1,000 that there's a bomb aboard this airplane. His buddy says, that's not too encouraging. That's still not that rare. No, I said, no, he says, you don't understand. If there's 1 chance in 1,000 of a bomb being aboard this plane, there's 1 chance in 1,000 squared, there's 2 bombs. In other words, 1,000 times, that's 1 chance, 1,000 times 1,000, which is 1 in a million. there's less than 1 chance in a million that there's 2 bombs aboard this plane. His buddy says, I don't see how that's so comforting. Well, I always bring my own bomb. Now you're laughing because you realize that those are not, that makes it, it's not unconditional, so that you puncture the model, obviously. That's why it's funny. But anyway, let's get back to these then. What's the probability? We've got these 8 prophecies to these. The reason I've used powers of 10, multiplying them is very simple. I just count the zeros. 1 in 100,000 times 100 times 1,000 times 100,000 times 1,000, 1,000, 1,000 times 10,000. Anyway, it turns out there's 28 zeros there. So I have 1 chance in 10 to the 28th of a person fulfilling all these. But it's not quite that simple because I've got to divide by the total population. And let's assume in this lifetime that we're talking about from Christ today, let's assume we add that all up. Let's assume it's about 100 billion, 10 to the 11th. So I have to divide the 10 to the 28th by 10 to the 11th. So I still have a very large number, 10 to the 17th. I can remember I sat on a board with Dr. Edward Teller, a famous scientist, changed the course of history 3 times personally. And we sat on a board together, and he and his sidekick were talking about 10 to the 17th, something or other. And I says, gee, that's interesting. I intruded myself in the conversation. He says, that's about as many seconds as there are in the universe. They looked at me startled. What are you talking about? Well, you're the guys who try to convince me that the universe is 14, 15 billion years old. If you do the arithmetic, that's only 10 to the 17th seconds. They looked at me stunned. Didn't realize that. There's only 10 to the 17th seconds in the history of the universe by your reckoning. And what interested me about that experience, they use these powers of 10 all the time. They're used to that, and they still didn't have a grasp to relate it. 10 to the 17th seconds is the history of the universe in seconds. That's a very big number, obviously. Now, what I want to do to get across how rare those 8 prophecies are is I want to get a bucket of silver dollars, okay? I want to mark one of them, but I need a bucket that will hold 10 to the 17th silver dollars. How many is that? That's a pretty big bucket. In fact, if I take the entire state of Texas and fill it with silver dollars 2 feet deep, I'll have approximately 10 to the 17th silver dollars. And so what we do is we mark one of them, and we mix them up so it has an equal chance of being anywhere. And we send one of you down into Texas, blindfolded, to reach down, and your chance of picking the one we marked is 1 chance in 10 to the 17th. That's pretty rare, isn't it? But we've only used 8 of these so far. We have 300 to choose from. So let me take another 8. Take 16. Now, I'm not going to go through another 8 prophecies. I have over 300 I can choose from. Now, the next 8 that I might add to our list of 8 are likely to be even more specific, more technical, which means they're even more rare. But I'm going to ignore that, and I'm going to presume, make a simplifying assumption here, that the next 8 are no more specific than the first 8. They're obviously going to be much more specific, but they're going to be less likely than the previous ones. But I'm going to ignore that. I'm going to assume no decrease in likelihoods of the next 8. So I got 10 to the 28th times 10 to the 28th. That's 10 to the 56th. I subtract by 10 to the 11th to get my 10. Now I got 10 to the 45th. Well, again, let me use I need a bucket here that has 10 to the 45th silver dollars in it, right? How big a bucket is it? The state of Texas isn't big enough. In fact, I need to make a ball of silver dollars that's got a radius of 30 times the distance of the earth to the sun. See, 10 to the 45th is a gigantic number. And that's probably underestimating the probabilities here, but let's leave that alone. Now, for this one, we need a space suit. We take our imaginary person, send him out there blindfolded, and he reaches into this ball 30 times. That's 30 astronomical units, 30 times. Anyway, and the chance of grabbing the one that's marked is 1 chance in 10 to the 45th. Okay, I'm going to do this only one more time. Instead of doubling, I'm going to triple it. We doubled it from 8 to 16. Now we'll triple it from 6 to 48. I got 300. I still have 300 to choose from. I got plenty to choose from. Again, I'm going to indulge in this fiction that the next group is not going to be more specific than the previous one. They're going to be actually far more technical and more narrow, but let's forget that. Now I have 6 times that, 10 to the 28th times all the way through. I now have 10 to the 168th power, and I got to subtract my 10 to the 11th out of that. Silver dollars won't work anymore. As I struggle to find a model here, now there's a number of us that use this approach. It was originally popularized by Peter Stoner in his book Science Speaks many, many years ago. And I'm really drawing on that approach. I made some corrections because there was some things that I felt needed correction. But anyway, silver dollars won't work here. I've got to think of another way to get across to you how big is 10 to the 157th power. Well, I'm going to make a ball of the smallest thing I can imagine, which is what, an atom. You probably have no grasp of how small an atom is, but it's probably the smallest thing as we can talk about. And I'm going to make a ball of every atom in the universe. Now, it may surprise you to discover there's a widely accepted guess by scientists. There's about 10 to the 66th atoms in the entire universe. Oh, really? Okay. Well, then I'm a long way from 10 to the 157th. If I imagine such a ball, I'm only at 10 to the 66th. Okay, I'll make such a ball for every atom in the universe. In other words, I'll do this 10 to the 66 times. Well, that's showing a promise. Now I'm up to 10 to the 132nd. I'm still a long way from 10 to the 157th. Suppose I do this exercise every second since the universe began. I'm going to repeat this exercise every second since the universe began. That gets me up to 10 to the 149. I'm still short of 10 to the 157. How much am I short? I'm short by 10 to the 8th. I have to do this 100 million times. This number is beyond our imagining. Stretch our imaginations as we might. Quantitatively, using every quantitative technique you can think of, there's no way you can get your mind around the probability of those 48 prophecies. And we've only dealt with 48 out of 300. What's the point of all of this? I am more certain that Jesus of Nazareth is the Messiah than I am of any other fact in the universe. I know of no other fact in the universe that I can be that certain of. I'm certain, that certain. And I've got quantitative evidence to prove it.